Here is, I believe this is part 4 of our video series. I think rather than do it mathematically, let's just logic this one out and see if we can figure out what x and y are without doing all this fancy math. So to determine the value of x, we need to have NO changing while H2 is staying the same. That's going to be experiments 1 and 3. And this is doubling. This is staying the same. And this one is times 4, I believe. So if the NO concentration, if when the NO2 concentration doubles, the rate goes by 4 times, that's going to tell me that 2 to the x equals 4, right? We double it, we get 4 times 2 to the x equals 4. X then equals 2. Right, so we're going to plug in a 2 up here for the x. And then let's look for one where H2 changes while NO stays the same. I think 1 and 2 will accomplish that. So this is no change. This is 2 times. This is 2 times. So if the rate doubles when the concentration doubles, 2 to the y then equals 2, so y equals 1. So our rate law then is rate equals K NO concentration squared H2 concentration to the first. There's my rate law. To calculate the rate constant, we're going to plug in for any of the 3 equations, or any of the 3 experiments, doesn't matter. I'll do, I don't know, let's do the third one this time. So rate, 4.92 times 10 to the minus 3 moles per liter per second, equals K, which we don't know. NO concentration is 0.2 moles per liter squared, 0.1 moles per liter to the first. So K, 4.92 minus 3 over 4.92 to the minus 3 divided by 0.2 squared divided by 0.1, 1.23, and the units are going to be moles per liter to the minus 2, second to the minus 1, right? Because we got moles per liter squared times moles per liter, which would be moles per liter to the third, and we're going to cancel one of those with this one on the top. Moles per liter minus 2, second minus 1. Overall rate order, reaction order, x plus y is 3. And the moles per liter is always one behind that. So third order, moles per liter is to the minus 2. Second order, moles per liter to the minus 1. Fourth order, moles per liter to the minus 3, whatever it turns out to be. So there's B and C. We're going to take 0.05 and 1.5. So rate, which is what we're trying to find, equals K, 1.23 moles per liter to minus 2 seconds minus 1, times 0.05 moles per liter squared times 0.15 moles per liter to the first. Moles per liter per second. 4.61 times 10 to the minus 4 moles per liter per second. All right, so that took care of that problem. These are all done approximately the same way. You might end up with the negative order at some point or a fraction order at some point. Don't sweat that too much. Just let it be what it is. The problems I want you to do, it looks like I've got 5 of them circled here. Get at least a couple of them, or at least get started on a couple of them. I'm not sure, I haven't worked them out yet, so I'm not sure what the answers are going to be, if any of them are harder than the others. But notice it's mostly write the rate law, calculate the rate constant, and calculate the rate when, just like what we've been doing there. So do at least a couple of those if you can, and hopefully I will see you on Wednesday.